The history of warfare has been a history of measures and countermeasures. When the airplane was invented, radar was later invented as a means of advanced detection of airplanes. Radar then spurred the development of its own countermeasures to hide airplanes from radar so they couldn't be detected. And today, these radar countermeasures are a key component of many military aircraft and sea vessels. Learn more about stealth technology, how it works, and why it was developed on this episode of Everything Everywhere Daily. This episode is sponsored by ButcherBox. You've probably heard the old adage that you are what you eat. Nowhere is this more true than with the meats and seafoods you consume. And that is why ButcherBox sources only the highest quality meats and seafood. All of their beef is grass-fed and grass-finished. All of their chicken is pasture-raised. And all of their seafood is wild-caught. They're able to do this by finding only the best producers who can meet their high-quality standards. Make a commitment to eat better this year with the best meat and seafood on the planet delivered directly to your door. ButcherBox is currently offering my listeners their choice of a weeknight meal essential: 3 pounds of chicken thighs, 2 pounds of ground beef, or 1 pound of premium steak tips for free in every order for a whole year. Plus, you get $20 off your first order. So sign up today at butcherbox.com/daily and use code DAILY to choose your free offer and get $20 off. This episode is sponsored by BetterHelp. We're far enough into 2024 now that most people have already forgotten about their New Year's resolutions. But that doesn't mean the things you wanted to change have necessarily gone away. Most of us don't need to overhaul our lives completely. Most of us simply need to recognize and focus on our strengths. It isn't necessary to make extreme resolutions. You just need someone to help you recognize what you're doing right so you can work on what needs improvement. BetterHelp is all about making professional counseling accessible, convenient, and affordable. With BetterHelp, you can connect with a licensed therapist from the comfort of your own home via online video sessions, chat, or phone calls. No matter where you are or what you're going through, BetterHelp is there for you. Just fill out a brief questionnaire to get matched with a licensed therapist, and you can switch therapists at any time for no additional charge. Begin identifying your strengths so you can work on the rest with BetterHelp. Visit BetterHelp.com/everywhere today to get 10% off your first month. That's BetterHelp, HELP.com/everywhere. In a previous episode, I covered the history of radar. And just as a quick refresher, radar is an acronym that stands for Radio Detection and Ranging. The technology, which was primarily developed in the 1930s, involves sending radio waves out into the air and then listening for the radio waves that bounce back off an object. The technology was deployed during the Second World War, and it was truly game-changing. The British adoption of radar helped them beat back the German Luftwaffe during the Battle of Britain. Radar gave the British early notification of when the German planes were on the way, and it told them approximately how far away they were and in what direction. And it wasn't just used to detect aircraft. In fact, one of the original purposes of radar was to detect ships as well. But this episode isn't about radar, as I've already done an episode on that. This episode is about the response to radar. Pretty much every military innovation in history has spurred another innovation to counter it. When humans invented swords, armor was developed to protect people from swords. And then crossbows and firearms were developed to penetrate that armor. When cities erected walls, siege engines were built to go over or through those walls. So too it was with radar. Once it became known that radar could detect objects from far away, the question became, how do you avoid radar detection? The secret to avoiding radar detection was really just a particular problem applied to part of the electromagnetic spectrum. For thousands of years, people have tried to avoid detection in another part of the electromagnetic spectrum, visible light. And we know this as camouflage. In the case of camouflage, you want to obfuscate an object so it's hard to see. Obfuscating radar was one of the very first things that was thought of. However, it isn't at all what you would call stealth. In fact, it's pretty much the opposite of stealth. It was called chaff. Chaff is the opposite of stealth insofar as instead of trying to minimize the radar signature of an object, you're trying to make it much larger. Chaff was nothing more than thin strips of radar-reflecting substances, usually aluminum or some other lightweight material with a radar-reflecting coating. Chaff is intended to blind or confuse radar systems. It might show up as a large blip on a radar screen, but that might hide how many aircraft were coming in and at what speed. Chaff was also the radio wave equivalent of a smoke screen. If you see a smoke screen, you know that somebody's there, but you don't know their numbers or exact location. Chaff is still used today for the same purpose in aircraft to throw radar-guided missiles off their course. If radar-guided missiles have been fired at an airplane, it can release chaff to confuse the missile and make it chase something else. So, chaff has a purpose, but it isn't ideal. What you'd really like to do is not be seen by radar at all. The Germans made the first efforts to reduce an object's radar signature during World War II. They created an experimental submarine known as U-480. U-480 was coated in a rubberized substance that could reduce the sonar signature of the submarine, and they also used materials that could reduce the radar signature as well. This is one of the first examples of the technique of trying to coat something in materials that absorbs radio waves. It was one of the first such attempts at coating something in radar-absorbing materials. The Horten-Ho 229 was a prototype aircraft built by the Luftwaffe in 1944. The airplane was one of the first flying wing aircraft, a triangular-looking plane where the entire body of the aircraft was a giant lifting device. One of the benefits of the flying wing design is that it has a lower radar profile than a traditional airplane with a round fuselage. These two techniques, pioneered by the Germans, absorbing radar waves and decreasing the radar cross-section of something, are two of the pillars of stealth technology to this day. After World War II ended, the Cold War began, which only increased the amount of research into stealth. One of the biggest needs during the Cold War was aerial reconnaissance flights. In the 1950s and 60s, the primary source of this information was spy planes, like the U-2 and SR-71 Blackbird, on which I've done a previous episode. These planes implemented a very small number of stealth features, but in the end, they really didn't have to do much. The U-2 just simply flew so high that almost nothing could touch it, and the SR-71 simply flew faster than anything else. One of the reasons why the government chose altitude and speed was because reducing a radar's cross-section was extremely difficult. The fundamental problem is this. The fuselage of almost every airplane is round like a cigar. This is because a rounded shape is the most aerodynamic shape. However, such a rounded shape means that no matter what angle a radar hits an airplane, it's going to bounce directly back at some point on its surface. The desire to create an aircraft that was primarily a stealth aircraft and had stealth technology front and center didn't happen until the 1970s. The U.S. Department of Defense launched Project Lockheed Have Blue, which was intended to create a stealth fighter aircraft. Strangely enough, much of the work conducted by the Have Blue team was guided by the 1962 work published by a Soviet mathematician by the name of Pyotr Yefimtsev. The work was titled Method of Edge Waves in the Physical Theory of Diffraction, and it laid the foundation for stealth technology. One of the principles laid out by Yefimtsev was the importance of the shape of the aircraft. The goal is to reduce the radar cross-section of an aircraft. And as I mentioned previously, a round shape is bad for radar reflection. What Yefimtsev determined was that you needed not a rounded surface, but rather a faceted surface, like the flat facet faces on a diamond. When a radar wave hits such a surface, it will bounce off not back to the radar receiver, but in some other direction. The principles behind making the radar cross-section of such an airplane very small were rather easy compared to the much more challenging problem of getting such a thing to fly. Despite the foundational mathematics for this problem being developed in the Soviet Union, they were unable to create such an aircraft because it took the power of a supercomputer to solve the equations, and the Soviets didn't have powerful computers. Lockheed eventually developed a prototype called the HB-1001, which was dubbed the Hopeless Diamond, due to its swept-wing diamond shape. The HB-1001 did fly, but more importantly, it served as the technical basis for what would become the Lockheed F-117 Nighthawk, which flew its maiden flight in 1981. The F-117 Nighthawk was designed and built in extreme secrecy. It was developed by the Lockheed Skuntworks facility and tested at the Groom Lake Test Facility in Nevada better known as Area 51. The F-117 Nighthawk was one of the most secret programs in U.S. military history. The aircraft was such a huge advantage that even most high-ranking officials in the Pentagon had no clue that it existed. It wasn't a particularly fast or maneuverable aircraft, but that wasn't its mission. It was a ground attack aircraft designed to slip past enemy air defenses and take out anti-aircraft radar and missile installations. In a conflict, the F-117 would be amongst the first aircraft used in a conflict to weaken or destroy radars and air-to-air missile batteries. Once that was done, then non-stealth aircraft could safely come in behind it and achieve air superiority. The F-117's existence wasn't publicly acknowledged until 1988. With the success of the F-117, there was a desire for a larger, more strategic stealth aircraft, one that could potentially deliver nuclear weapons and would be difficult to detect or intercept. This resulted in the Northrop Grumman's B-2 Spirit, also known as the B-2 bomber. The B-2 has a flying wing design like the Horton Ho 229. It saw its first test flight in 1989 and was fully deployed in 1997. Both aircraft have been deployed in various conflicts over the last 30 years, and both aircraft also have radar-absorbing surfaces. The surfaces of the planes are made out of materials with very irregular shapes on the microscopic level. It's basically the faceted approach to the plane design, but just much smaller. The lessons learned from the F-117 and the B-2 have been incorporated into other programs, such as the F-22 Raptor and the F-35 Lightning II. There have been aircraft developed by other countries with various stealth attributes. The Russian Sukhoi Su-57 and the Chinese Chengdu J-20 are both fighters with some stealth attributes, but they were not designed to be stealth-first aircraft. Stealth technology isn't just for aircraft. It's been incorporated into ships as well. The USS Zumwalt is a guided missile destroyer that has a radar signature of a vessel just a fraction of its size. At the start of this episode, I mentioned that every innovation in warfare leads to some counter-innovation. If stealth was created to thwart radar, then is there anything that can thwart stealth technology? Is there a counter to the counter? And the answer is, not surprisingly, yes. The biggest one is low-frequency radar. Stealth aircraft are primarily designed to evade high-frequency radar, which is commonly used for tracking and targeting. Low-frequency radar, on the other hand, can be more effective against stealthy designs because lower-frequency wavelengths are less easily absorbed or deflected by the materials and shapes used in stealth technology. Another stealth counter technology is multi-static radar. Multi-static radar systems use multiple transmitters and receivers placed at different locations. This setup increases the chances of detecting stealth aircraft by capturing the radar reflections from various angles, potentially exploiting any radar reflective vulnerabilities in the aircraft's design. Non-radar methods of detection are being proposed as well, including acoustical detection, electromagnetic detection, and infrared detection, trying to pick up the heat signature of a plane. Stealth technology remains a key element in modern military strategy, embodying a continuous cat-and-mouse game between detection and evasion technologies. The technologies and techniques developed in the very first generation of stealth aircraft will, at some level, be incorporated into future military aircraft for years to come. The executive producer of Everything Everywhere Daily is Charles Daniel. The associate producers are Peter Bennett and Cameron Kieffer. I wanted to give a big thanks to everyone who supports the show on Patreon. Your support helps me put out a new show every day. And if you're interested in Everything Everywhere Daily merchandise, Patreon is currently the only place where it's available. And if you'd like to talk to other listeners of the show and get notified of future episodes and projects, please join my Facebook group or Discord server. Links to everything are in the show notes.